I'm Alexandra from Datatonic. I'm a data scientist. So we are at Datatonic. We are a machine learning consultancy. We work on projects with clients focused on machine learning, analytics, and data engineering. So we had this client, a global cosmetics retailer, and so they basically manufacture handmade bath bombs and shower cream and many types of creams, and they have many shops all around the world. The goal is to eliminate packaging, like plastic and paper packaging, altogether from their shops and from their products. Can we go to the next slide, please? And they found us and wanted us to create them an image classification model which is capable of recognizing products. So they don't need to put any ingredients or any description on a packaging, but all the information is in the app. So they already had an Android and iOS app, which they used for many other purposes. And they wanted to build in this feature. So we worked with this internal innovation team, whom are a group of very smart developers. They are not machine learning engineers or data scientists, but they had a very good technical literacy. So they wanted a high-performant, mobile-friendly model, which has a small size, of course, and they wanted also fast inference. So the task basically is to develop an image classification model which is capable of operating both on iOS and Android devices. And they also wanted us to automate the pipeline of retraining the model and evaluating the model if they have new images or new products they would like to train it on. They also provided us with 50,000 images on Google Cloud Storage of around 400 products, and this was our base. So, can we go back to here? So they already had a CoreML model. CoreML is Apple's machine learning framework, which works very well with iOS. So they trained this model on these 50,000 images. They thought it's working very well because they had super good training results, but they didn't have a test set. So when they went out and tested their model in real life in the shops, it didn't work very well. So they needed experts like us to fix this problem. Next slide, please. So why mobile is so special? So mobile needs very optimized solutions, mainly because it has very limited resources. And also machine learning models can have very large size, and also the calculations can be very processing heavy. So the solution for this is TFLite, which is a framework within TensorFlow, which makes it which is capable of bringing TensorFlow models onto mobile devices. Can we go to the next slide, please? So TFLite has two components. One is the converter. Converter makes it possible to convert TensorFlow models, which you train with TensorFlow code or with Keras, and convert it to TFLite format, which is an optimized compressed format, which can be put into a mobile app and can be downloaded with a mobile app and hosted, stored on a mobile device. And the inference happens on the mobile device offline. So it is actually very fast. It doesn't need internet connection to work. And you can use any TensorFlow model, which is compatible with the TFLite. I'm going to talk about this in detail. Can we go to the next slide, please? So TFLite doesn't support all operations in TensorFlow. So it has some constraints. When you think about your model design, you can't use any model. It has supported models, for example, MobileNet or Inception. So MobileNet is a very lightweight model that we choose to use. It is one of the supported models. So we thought just to keep our flexibility, we use Keras and TensorFlow to build and train our model. But then it turned out that actually the Keras MobileNet implementation has operations which are not supported within TFLite. So we had to go to the Keras MobileNet source code and change some operations. And actually it seems very easy to, in the documentation it is described that it's very easy to use TFLite, but when you come across this problem, you actually really need to know what operations are in the MobileNet architecture within Keras. And when you are there, you're like, I've never heard of this before, and you have to, change the architecture. And then, so we ended up having a custom MobileNet implementation, which then we were able to convert into TFLite format. Also we used ImageNet weights too, with transfer learning to train our model, and we only trained the last layer of the model. And then we evaluated this model on our test set. So we also evaluated their original CoreML model, and so for the CoreML model we got 38% accuracy, and for our MobileNet model we were able to perform with 80% accuracy, so it was a nice improvement. Next slide, please. So we have now this TFLite model. We have the images on cloud storage, but they also asked us to provide them with some automated way to retrain this model, to store the models, to version them. Next slide, please. So we have the TFLite model. Next slide. We have the images, and we have the apps in the end. Next slide, please. And how to connect all these. So this is the machine learning pipeline we built. Not this, but it solves this problem. Next slide, please. So what we want to do, we want to pre-process the images. We want to somehow feed them into the machine learning model from GCS. And then we want to automate the training and evaluation of the models. We want to somehow store the evaluation metrics. And we also want to store the models somewhere that we trained and version them and have the most up-to-date version. Next slide, please. So this is our pipeline solution. It's quite long, so I'm just going to highlight a few things. So we have these two stages, the data preparation stage and the machine learning stage. So within the data preparation stage here, we have the images on GCS. That is where we're starting from. We converted these images into TF records, which are serialized images within binary files, in 100, 200 megabyte binary files. It works very well with TensorFlow, easy to read, so that's why we put them there. So we then stored the train and evaluation sets on GCS. We applied some data augmentation. We wanted to simulate or mimic the different lighting conditions in the shops, or they imagined that customers would use these apps in their bathrooms as well. So we wanted to somehow mimic these conditions with the data augmentation. So that's about the data preparation part. And then we use AR platform, or back then ML engine, to train and evaluate the model. Within that code, we converted the model to TFLite, and we saved all the model versions in GCS and just simply versioned them with a timestamp. We stored all the evaluation metrics in a BigQuery table. We also implemented a condition here. So we had a minimum limit of F1 score. If the model couldn't reach that score, then we didn't export the model and didn't save it. We automated this whole pipeline with Cloud Composer, which is a managed implementation of Apache Airflow, a very nice product. So they improved our pipeline. These are the most important improvements they made after we handed them over. So they improved the way of detecting new images on GCS. They also added a Slack integration. So they got a Slack message every time they retrained the images. So they got the F1 score and accuracy as a Slack message, so they could easily monitor the training and didn't have to go to the BigQuery table and check it there. They also added core ML conversion to the TensorFlow code because it turned out that TFLite can be, they converted the TFLite model into core ML because it was much easier to integrate it into the iOS app, but it's still the same model. Yeah, and all this is a very fancy pipeline and we did a lot of fancy stuff, but actually what made the biggest difference in the end is that when we looked at the images, like all the images look like some one color background and some central object in the middle. So usually in a shop, products are not placed like this. They are in a basket with a lot of other products together, so it wasn't really realistic. And what made really the difference is that we requested more images from real life environments, and that really boosted our results or the model results. So we enriched the data set, and in the end that made the biggest difference. Yeah, and so they actually released this app in April. They have naked shops already in Japan and the UK, where there are no packaging at all, so you have to use the app to recognize the products and get some information of them. In the future they would like to implement this feedback loop, which means that they would like to make use of the customers who use the app and get some feedback if the model performed correctly or not, and also get the images that the customers took with the app. Yeah, and we are also hiring, and we are Datatonic, and there is the link, and this is our team, and thank you so much.